And we need to talk about the remainder theorem. In order to understand the theorem, the truth about the remainder, let's take a look at this. Simple question. Is 4 a factor of 8? Yes or no? Yeah, 4 is a factor of 8. Okay, so how about this? 8 divided by 4. Will I get a remainder? No. You got a 2 right here. That's an 8. Subtract. No remainder, right? So what we're seeing here is actually the theorem, the truth that I want you to understand. And the truth is, when you take something and divide by its factor, you're not going to have a remainder. And especially for this section, since we're not just talking about taking something and dividing by its factor, we're talking specifically about polynomials in this section. So everybody should jot this down in their notebooks. When you divide a polynomial by a factor of that polynomial, your remainder will be 0. And this makes total sense. We're looking at it right here with simple numbers. When you take something and divide it by its factor, and we know 4 is a factor of 8. When you take something and divide by its factor, the remainder will be 0. Got it? So in order to really understand this theorem, I'm going to tell you that x plus 2, the binomial x plus 2 is a factor of this huge polynomial. Okay, so I'm telling you x plus 2 is a factor of this cubic polynomial x to the third plus 4x squared plus 1x minus 6. Okay, now what does that mean? That means if I were to take this guy and divide it by this guy, what would my remainder be? 0, right? That's what this fact is telling us, the remainder theorem, the truth about remainders. If your remainder is 0, then that means that this guy really is a factor. And I'm telling you, this is a factor of this. So if I take this and divide by x plus 2, our remainder will be 0. Do you guys remember long division? Was that fun? No, it wasn't. Okay, what was the easier option instead of long division? Synthetic. So you know what? Just for kicks, check this out. I'm going to use synthetic division to show you that the remainder is 0. Okay? So if I wanted to divide this guy by this guy, in synthetic division, you'd put the box. Now remember, this is not synthetic substitution. This is synthetic division. So what value goes in here? Exactly, -2. So in synthetic division, you do have to put the opposite of the number you see here with x. So if it's a +2, you're going to put a -2. And then we're going to put our coefficients of the polynomial. And the coefficients are 1, 4, 1, -6. Yay? Okay, and we are going to do synthetic division just to show you that this is the truth about the remainders. It's going to be 0. All right, so check it out. The 1 comes down, and then -2 times 1, what do I get? -2. And then as we go down, 4 and -2, what do we get? We get 2. Okay, and as we go this way, -2 times 2, what do we get? -4. And then as we go down, 1 and -4, what do we get? -3. And as we go this way, -2 times -3, what do we get? 6. And guess what? This is our remainder. And what's our remainder? 0, of course. So I just proved, first of all, I know for a fact, I got this from a problem. I know for a fact that this is a factor of this. So the remainder is 0. So what I've done here is proven the above fact that when you divide a polynomial, by a factor of it, you end up with 0 as a remainder. So this fact could become useful. Like, for example, if I say, is x plus 2 a factor of this guy? Well, how could you check? You could check and see if you get 0. And if you do get 0, then you know for a fact that this is a factor. Does that make sense? Like, let's say I asked you, is x minus 1 a factor? All right? Like, what if I asked you that? Same exact question, but let me actually do this. So I want to move this out of the way. And that was for the question, is x plus 2 a factor, or just to prove that it does work. But what if I asked you, is x plus 3 a factor of the above, right? Is x plus 3 a factor? How could you check that? How could you check if x plus 3 is a factor? Synthetic division. So what would we plug in? Negative 3. And what are our coefficients? 1, 4, 1, negative 6. Okay? So as you come down, you add. 1 plus nothing is 1. As you go up, you multiply. Negative 3 times 1 is negative 3. As you go down, you combine. 4 take away 3, 1. As you go up, you multiply. Negative 3 times 1, negative 3. As you go down, you combine. 1 minus 3, negative 2. As you go up, you multiply. Negative 3 times negative 2, 6. So what does that tell you? Or could you answer the question now? Is x plus 3 a factor? Yes, it is. How do you know? Because the remainder is 0. Right? And whenever the remainder is 0, the remainder theorem says that it has to be a factor. Cool? So that's one way you could use the remainder theorem. Another way is, what if I said, okay, we already know for a fact that x plus 3 is a factor. So here's another type of question that you're going to see. Find all other factors, and we're still dealing with the same cubic polynomial up here. Find all other factors given that x plus 3 is a factor. So they're telling you x plus 3 is a factor. What does that mean? If you did synthetic division, your remainder is going to be what? 0. Okay, so we just said the remainder is going to be 0. So let's actually show that the remainder is 0 and show you how else you could apply this synthetic division. All right, so inside the box, we're going to have what? Negative 3. Okay, and the coefficients are, once again, 1, 4, 1, negative 6. We just did this work, didn't we? Yeah. Okay, well, we have a 1 right here, we have a negative 3 up here, we have a 1 down here, we have a negative 3 up here, we have a negative 2 right here, we have a positive 6, and of course, the remainder is 0. We already knew that. So why would I do this if I already know it? Because they're telling us that x plus 2 is a factor. So if they want us to find all the other... Oh, no, wait, I'm sorry. That's not what they're telling us. We already figured that out, but let's scratch that out. It says, find all the other factors given that x plus 3 is a factor. Okay, so we took this. We showed that the remainder is 0. Now, I know that this is a factor, so what I could do is write x plus 3, that's a factor, and it times something else. Now that something else is going to come from these bottom numbers. This is the constant, so you're going to put minus 2. And then we have a 1x that's positive. And then we have an x squared that's positive. Does that make sense? Yeah. So this is a way to find all of the factors given one factor. So they gave you one factor. They gave you x plus 3. We proved that the remainder was 0, but we use these numbers to come up with the remaining polynomial. Now, this remaining polynomial could be factored further. So let me factor it further. In other words, they already told us that x plus 3 was a factor, that's for sure. But this red quadratic trinomial could be factored further. What times what is negative 2? Wow, that's disgusting. Hold on a second. Could I erase it? Yes. Here's a better x. Okay, so what times what is negative 2 that if you add together is positive 1? That'd be a positive 2 times a negative 1. Ladies and gentlemen, we have completely factored the original cubic polynomial given the fact that they gave you one of the factors. That's a skill that we have to do on today's homework and on tomorrow's quiz. So they're going to give you a factor and you're going to use synthetic division to be able to come up with the remaining polynomial, and then you're going to try to continue factoring. Let's try another example. So let's jump to our homework. Let's go to the hardest question there is on our homework. It's number 21. It's the last one. On our homework, we're doing page 355, 1 through 21 odd. Let's go to the last one, the most challenging one. and they tell you that you have a polynomial and they give you a factor. This binomial is a factor of this thing. Now, using the remainder theorem, we should know that the remainder is going to be 0 if we divide. And what we're going to do is use synthetic division to be able to get that remainder, show the remainder 0, and then be able to use the numbers at the bottom to be able to write our remaining polynomial. So what belongs inside the box? 1. And give me the coefficients. 2, 17, 23, negative 42. Okay? So we have the line right here. As you go down, you add 2 plus nothing is just 2. And then as you go this way, 1 times 2 is 2. And then 17 and 2 is 19. And then 1 times 19 is 19. And 19 and 23 is 42. And 1 times 42 is... does this surprise anybody that the remainder is 0? Of course not. As a matter of fact, if your remainder is not 0, then you know you did something wrong, because they're already telling you it's a factor. So if it's a factor, it has to be the remainder 0. Okay? So if you get something else here, you must have done a mistake, which means that these numbers are not right. And these are the numbers that we're going to use. Okay? Now, what do I mean by these are the numbers we're going to use? We're going to use those numbers. What the heck? This 2 belongs right there. We're going to use those numbers to be able to write it in factored form. So if they told us that x minus 1 is a factor, I might as well write it over here on the side. X minus 1 is a factor. Now what else is left over right here? Inside we have a 2x what? Squared plus 19x plus 42. Okay? Now we need to continue factoring if we want to find all the other factors, if possible. Now in here it's ugly. Like I said, this is one of the harder ones because we still need to factor this, and the best way to factor it, because the a value is not 1, is to multiply a times c and go through that whole process. So a times c is 84. Now we need to think of the multiples of 84 that combine together to give us 19. So you might as well make a list for step number 2. So I made my list, and of course I used the calculator to help me out with this list. And if you look at all those possible pairs of numbers, which pair gives you 19? 7 and 12. Step 3 is to rewrite the 19x in the middle as these two terms, 7x plus 12x. So once again, instead of this 19x, I wrote it as 7x plus 12x, which is the same thing as 19x. And now all we need to do is factor by grouping. Moved it up to get more space. Okay, so the first group, we have 2x squared plus 7x. What could I factor out? An x. What do I have left over? 2x plus 7. The second group, what could I factor? So the second group, you can't pull out a 12. You could pull out a 2, but what's the highest, or the GCF that you could pull out, which would be 6. So let's pull out a 6, a positive 6. And what would you have left on the inside? 2x plus 7. Now it's the same exact binomial, 2x plus 7, both in red. Let's pull that out of the whole thing. So what I did was take this 2x plus 7 and pulled it out of the whole thing, and we have the x left over and the 6 left over. Now, keep in mind, this is the factored form, 2x plus 7 and x plus 6. But where did this even come from? We have to go back up here. This came from this, and we still have the x minus 1. So, ladies and gentlemen, right here are all three factors of the original polynomial equation when they give us x minus 1 being a factor. So the other factors are 2x plus 7 and x plus 6.